Hello, this is Eduardo Suarez. In the second part of this video, I show you a Palletizer program that uses two KAREL programs, one for defining the pallet pattern information and the second for defining the place position of the boxes. In this third part of the video, we're going to change the pattern information and we're going to add the flip layer, and we're going to see if the program is still able to handle that. We're going to start by looking at the parts. Here I have two new parts. It's a box 2 normal and box 2 flipped. If we go to properties, you're going to see that the width is the same and the height is the same. And what I did, I doubled the size for the length. If we go back to the box 1 normal, you're going to see that the length, this one is the size, half the size of the length of the box 2. I'm going to add the box to the box and feed conveyor. We have the box normal and the box flipped. And on the pallet of feed conveyor, I also added the parts. I have the box 2 normal and the box 2 flipped. You're going to see that now, instead of 13 boxes, we have only 6 boxes. And also I changed the pattern information to something quite different. And one more thing you're going to notice is that the boxes are hanging out of the pallet, so we need to add a small offset in here. We're going to be adding an offset on the -X to shift all the boxes on the X direction. Look at the gripper. On the gripper I also have on parts. I have the box 2 normal and the box 2 flipped. If you look at the KAREL files, before we have B1 pattern definition, and now we're going to have box 2 pattern definition. This KAREL program is a copy from box 1 pattern definition. The only thing I did, I changed the name to box 2, and I changed the number of boxes to 6 instead of 13. For now, we're going to keep the number of layers to 1, and we're going to do the simulation before we change to 2 layers. And you're going to see here on the executable section of the program that I have the box turn for box 1 is going to be false, and for number 6 is going to be false, and the other boxes are box turn is true. Here is where I'm adding the additional offsets of -15 millimeters to take into account the shifting that we need to do for the boxes. And in here I have the dependencies. We can look again to the Excel sheet, and here I have the order of the boxes I'm going to be putting on the pallet. We have box index 1 that doesn't have any dependency and the box turn is false. Then the second box is going to be index number 2, that on the X is going to depend on box index number 1, and on the Y that doesn't have any dependency. Similarly, for box index number 3, on the X is going to depend on box number 2, and on the Y doesn't have any dependency. When we go to box number 4, on the Y doesn't have any dependency, it has a dependency on the X, on box index number 1. 5 is going to have 2 dependencies, and number 6 is also going to have 2 dependencies. And you're going to see here with the X arrow the position of the X offset and the X position and the Y position for each one of the boxes. we're going to keep the position register 2 exactly in the same position as before. That's not going to change. So if we go back to the KAREL program for the box 2 pattern definition, that's all that we have to do. We're going to keep for now the number of layers to 1, and it's not going to be flip, it's going to be a normal layer. I have the B2 set position. Again, this is going to be a copy from the B1 set position. I'm renaming the file. I'm going to change the number of boxes to 6. I'm going to change the box length to 770 millimeters. And I'm changing all the reference for the pattern definition to box 2, as you can see on this part of the progress. And everything else remains exactly the same. We don't need to make any changes on the executable section of the program. We're going to have to, that's going to be for simulation, the B2 pick KAREL program. This one is going to be looking at the number of layers, and it's going to be making a reference to B2 pattern definition, and we're going to be calling the B2 normal pick simulation or the B2 flipped pick simulation. And similarly for the B2 place KAREL program. In this case, we're going to call the B2 normal place simulation or the B2 flipped place simulation. If we look at the simulation programs, we're going to go to the B2 normal pick, and we're going to pick the box 2 normal from the infill conveyor with the servo gripper. We're going to have the same for the B2 flipped pick simulation, and similarly for the place simulation. So now, one more thing that we need to look at is going to be, we're going to open the teach pendant, and we're going to look at what we have in here on the registers. We're going to change the register number 4 to number of boxes is going to be 6 instead of 13 that we have before. We're going to keep the number of layer to 1. And if we go to the position registers, nothing changed. We have the same home position, we have the same position register 2 for the start position. We're going to look now at the TP programs. We're going to have this one is going to be a copy from the B1 main side. The only difference is going to be that now I'm making reference to the B2 parent definition, and we're going to be calling everything else with B2 instead of B1. We're going to have the B2 pick, and we're going to have the B2 place. If we look at the B2 pick, again, it's going to be a copy from B1 pick, and we're going to just change the reference when we call the simulation program to B2 pick KAREL program. And also you're going to see that I change the position for the P1 and the P2, because now still we're going to do the qualify. We're going to qualify the box 2 in the same way that we qualified the box 1. So now the peak position changed. Locked. And we look at the B2 place. The only difference is going to be we're going to be calling the KAREL program B2 set position and the simulation program for B2 place KAREL program. And everything else is going to come from the position register 20, 21, and 22 are going to be defined on the B2 set position. So we can give it a try. We're going to select again B2 main, and we're going to see what happened now. Just remember that I haven't made any changes to the executable section of the KAREL program for the set position. I'm going to run the simulation. That was index number 1. We're going to pick index number 2. We're going to pick index number 3. Number 4. Number 5. Finally, number 6. So you can see that the same KAREL program was able to handle a pattern that is quite different from the pattern that we have on the second part of the video. What we're going to do now, we're going to add one more layer, and we're going to change the layer to flipped and see what happened now. Now I added the second layer to the palette. It's the box there shown in blue, and we're going to see the changes that we need to make. We're going to look first at the pattern formation. Here I have side by side on the left layer number 1, that is the normal layer, and on the right layer number 2, that is the flip layer. You can see that I changed the position of the boxes. We're going to start with box index 1, that's going to be turn, index box is going to be turn, and index 3 is going to be in the normal position. And then we go to 5 and 6. So now our table has changed, and we need to reflect these changes on the KAREL program. We're going to go back to the KAREL program, and we're going to open the box 2 pattern definition. First change we're going to change the number of layers to 2, and when we go to the executable section of the program, now we're going to have, in addition to the box normal, we're going to have the box flipped. And in the box flipped, we need to assign the values for each one of the elements. with the box turn, the additional offset, and the dependencies, as the way that I show you on the Excel sheet. And finally, we're going to add a second element to the layer, and in this case, flip is going to be true. Notice something here, that when you make changes to the declaration section of the program and you try to compile, you may have some errors in here. And the reason for that is because you already have a previous variable program. So what you need to do, you need to go back to the teach pendant, and you need to delete all the, let's go back over here. You need to delete all the programs that are PC and variables. When you delete all the variables and PC programs, you can go back and you should be able to build the program again if you don't have any errors. Okay, so now, because we have the number of layers 2, we need to make the same change on the pick program and on the place program. We're going to look at the changes that we need to do on the set position. So we're going to open the set position. This is the same program that we had before for layer number 1. So first thing, we're going to change the number of layers to 2. And you're going to see the changes that I'm going to make now. So on the declaration section of the program, after the variables and before the executable section, we're going to write the instruction routine, begin and end. And we're going to take part of the executable section. We're going to delete it from here, and we're going to paste over here. So now we're going to take this, change where it says box normal. We're going to copy that. We're going to go to replace. And we're going to change this one from box normal to box. Okay, and we're going to make one more change where it says position register place. We're going to copy that, and we're going to do another replacement. I'm going to call it place. Okay, now we need to change this routine. We're going to add the parameters that we're going to use for calling the routine. And it's going to be all this. So we're going to call the routine position layer normal. And we're going to pass as a parameter the box, the place position, box number, the offsets on the X, Y, and Z, and the box length and the box width. Now we're going to take this routine, we're going to copy, and we're going to place over here, and we're going to change the name from position layer normal to flipped. So now what I've done, I change the executed section, I move it to the routine, and we're going to handle that inside the routine with the parameters. So we need to call these two routines, and we're going to call it underneath. So what we're going to do, we're going to come in here, and we're going to add an if instruction that is going to be looking at the layer. If the layer is flipped, we're going to call the routine position layer flipped, and we're going to pass these arguments. Otherwise, if it's a normal layer, we just call the routine with a normal layer, and we are going to pass exactly the same arguments. Notice that the arguments are by reference, so we don't need to return anything from the routine. All the values are going to be written on the same position register, for example, that we have in here. On the position register place. So we're going to give it a try. We're going to save this one. We're going to see if we can build without any errors. Yeah, translation was successful. And we're going to close this part. Now we're going to go to the teach pendant. We're going to go to data. And we're going to change the number of layers to 2. And you can change the number of layers, the number that you want. 2 is going to be enough for us for proving the program. Now we're going to select the main program. Nothing changed over here because the only changes that we're making is the number of layers, and that's already taken on the register. So we're going to select this one, and we're going to run the simulation. can see that we were able to create a Palletizer program that is able to handle different pattern formations, is able to add offsets either when we need to create offsets inside the position of the boxes on when we have to shift all the boxes on the pallet, and also is able to handle different layers with different orientations. Something that I want to notice in here, that is a Palletizer program, is not going to be a replacement for Pallet Pro. Pallet Pro is a more powerful package than what we're doing here. But if you have a small project that you have a limited budget, that you know that you're going to have a few pattern formation, and the pattern formation they're going to change during the time, you're not going to need any recipes. So this would be a good option. And again, this is just I'm giving you the tools, and you can work on this one and make your own changes. So I'd love to hear from you. If you can leave in the comments below, what do you think? As always, there is so many ways you can use Palletizer programs. I'm pretty sure you may have something, another way to do that with the same result. Finally, I'm going to leave a link to the work cell on the description below.